The question of whether wire nuts are a sufficient means of splicing for ballast, specifically when dealing with 277 volts ballast, requires careful consideration of the National Electrical Code, or NEC, and best practices for electrical installations. The NEC provides guidelines for splicing electrical conductors, and it's crucial to ensure that any splicing method complies with these requirements. Wire nuts are a common and generally accepted method for splicing wires, but their suitability depends on several factors, including the specific application, voltage level, and adherence to proper installation techniques. Firstly, let's consider the general requirements for splicing conductors. The NEC section 110.14 B addresses splicing. It states that splices shall be made with splicing devices identified for the use. This means that the wire nuts used must be listed and labeled for the intended application, voltage, and conductor size. The listing typically comes from a recognized testing laboratory such as Underwriters Laboratories, or UL. Secondly, when splicing wires for 277 volts ballast, it's imperative to use wire connectors that are rated for at least 300 volts. Standard orange wire nuts might be rated for lower voltages, so using them for 277 volts applications could violate the NEC and create a safety hazard. The wire nuts packaging or labeling will indicate its voltage rating, so it's essential to verify this before using them. Thirdly, the NEC also requires that splices be made in a way that provides secure electrical and mechanical connections. This means that the wires must be properly twisted together before applying the wire nut, and the wire nut must be tightened sufficiently to ensure a firm grip on the conductors. The goal is to prevent loose connections, which can lead to arcing, overheating, and potentially fires. Fourthly, the type of wire nut used is also important. While standard wire nuts can be suitable for some applications, there are also wire nuts with internal springs or other mechanisms designed to provide a more reliable connection, particularly in applications subject to vibration or thermal cycling. These types of wire nuts might be a better choice for ballast splicing, as ballasts can generate heat during operation. Fifthly, the question mentions the use of orange wire nuts without a coil. It's important to clarify that the presence or absence of a coil inside the wire nut can affect its performance. Wire nuts with coils, often referred to as winged connectors, are generally designed to provide a more secure grip on the wires, especially when dealing with a large number of conductors or conductors of different sizes. However, the absence of a coil does not necessarily mean that the wire nut is unsuitable, as long as it meets the other requirements for voltage rating, listing, and secure connection. Sixthly, let's address the specific scenario described where the electricians are putting the three ballast wires together and wire nutting them. This practice is acceptable as long as the wire nuts are properly sized for the number and gauge of conductors being joined and all other requirements are met. The NEC provides tables that specify the maximum number and size of conductors that can be used with different types of wire connectors. It's crucial to consult these tables to ensure that the wire nuts are not being overloaded. Seventhly, in addition to the NEC requirements, it's also important to follow the manufacturer's instructions for installing wire nuts. These instructions typically provide guidance on how to strip the wires, twist them together, and tighten the wire nut. Following these instructions can help ensure a reliable and safe connection. Eighthly, it's worth noting that some jurisdictions may have local amendments to the NEC that impose additional requirements for electrical installations. Therefore, it's always a good idea to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Ninthly, while wire nuts are a common and generally accepted method for splicing ballast wires, there may be other splicing methods that are more suitable in certain situations. For example, terminal blocks, butt splices, or other types of connectors might be preferred in applications where space is limited or where a more robust connection is required. Tenthly, it is always a good practice to perform a pull test on the completed splice to ensure that the wires are securely connected. This involves gently pulling on each wire to verify that it does not come loose from the wire nut. If a wire pulls out, the splice should be redone to ensure a reliable connection. 11thly, regular inspection and maintenance of electrical connections are essential for ensuring the continued safety and reliability of the electrical system. Over time, connections can loosen due to vibration, thermal cycling, or corrosion. Therefore, it's important to periodically inspect wire nut connections and tighten or replace them as needed. 12th, the use of proper personal protective equipment, or PPE, is essential when working with electrical circuits. This includes wearing safety glasses, insulated gloves, and other appropriate gear to protect against electric shock and other hazards. 13th, it is important to de-energize the circuit before working on any electrical connections. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. This will help to prevent accidental electric shock. 14th, when working with 277 volts ballast, it's especially important to take precautions to avoid contact with live electrical parts. The high voltage can be lethal. 15th, proper grounding is essential for electrical safety. All electrical equipment, including ballast, must be properly grounded to provide a path for fault current to flow back to the source. This will help to prevent electric shock and reduce the risk of fire. 16th, the NEC specifies requirements for grounding electrical systems. These requirements vary depending on the type of system and the voltage level. It's important to consult the NEC to ensure that the grounding system meets all applicable requirements. 17th, when replacing ballast, it's a good idea to use ballasts that are energy efficient and meet the latest industry standards. This can help to reduce energy consumption and lower operating costs. 18th, some ballasts contain hazardous materials such as mercury. When replacing ballast, it's important to dispose of the old ballast properly in accordance with local regulations. 19th, it is crucial to label electrical panels and circuits clearly. This will help to make it easier to identify and troubleshoot electrical problems in the future. 20th, consider documenting all electrical work performed, including the date, the type of work performed, and the materials used. This documentation can be helpful for future maintenance and troubleshooting. 21st, it's essential to have a thorough understanding of electrical safety principles before working on any electrical equipment. This includes understanding the hazards of electricity, how to protect against electric shock, and how to safely de-energize circuits. 22nd, if you are not comfortable working on electrical equipment, it's best to hire a qualified electrician. Electricians have the training and experience necessary to perform electrical work safely and correctly. In summary, using wire nuts for splicing ballast wires is permissible under the NEC, provided that the wire nuts are listed and labeled for the intended application, voltage, and conductor size. The splices are made in a way that provides secure electrical and mechanical connections. The manufacturer's instructions are followed, and all applicable codes and regulations are complied with. If there is any doubt about the suitability of wire nuts for a particular application, it's always best to consult with a qualified electrician or electrical inspector.